on this accelerated infrastructure as a AI initiative, which is actually enabling the artificial intelligence in a wider term. So now let me just give you some brief background about what is this accelerated infrastructure, okay? So before I move into this, I would like to know from all of you, what do you really, what comes to your mind when you think about artificial intelligence? I mean, what is artificial intelligence mean? Anyone? Okay, okay. Any more thoughts? Okay, okay. Sorry? Okay, okay, okay. But why we are calling it as a artificial intelligence? Anyone want to share the insight? Okay, we'll come back to you. Okay, maybe you will be able to answer it much better after I present this. Okay, so when we call it as a accelerated infrastructure, we mainly talk about three domains which are really important for having this accelerated infrastructure. First is a compute, second is a connectivity, and third is a storage. Hmm? So when you say all these large language models or fast computing, pattern matching, everything if you see, it comes under compute as a domain. Hmm? Uh, and after compute, you must be seeing that I have written as a XPU. Hmm? So this is a very general term that we are calling. It could be a CPU, it could be a GPU, it could be HPU. Everything is serving on this compute as a domain. So as a generalized term, we are calling it as a XPU. Whoever is contributing on this is actually solving the compute needs of this accelerated infrastructure. After compute, there is a connectivity. You will compute the things, but anyways, those needs to be communicated to some other place. That needs the connectivity. So this connectivity aspect, it needs switching as well as interconnect. So these are the two subdomains you can call, which comes under connectivity as a domain. And then it comes storage. Storage, all of you know that we need a lot of data to be stored. So mainly it is all the storage controllers, they come in the storage as a domain. So when you say about artificial intelligence, okay, you will immediately say that it is kind of chat GPT. Okay, so what does that chat GPT do? You ask some question to that prompt, and you expect some answer. That answer is not something that you can get by reading one paragraph of a book. That particular question needs to know lot of data related to that area. For that, it needs to first search and find out the relevant data, then try to find out the area which are very specific to the question that you are asking. All of these things come under compute. It needs lot of computing because there is lot of search involved, there is lot of pattern matching involved, lot of shortlisting involved. All these things come under compute. Hmm? Then comes the connectivity. So when you actually give something on the prompt, okay, the data may not be easily available to the engine that is processing your needs, and it is not a case that only a single engine is working on your query. Multiple engines are working in parallel. The data is located at multiple places. So the connectivity portion makes the switching as well as the interconnect aspect of this domain. They try to find out the data. For that, they need to reach to different areas where the data is stored. Plus, they need to switch between, let's say, first the data processing happen by one engine, then it needs to be processed for further search or pattern matching, then that particular data will be switched to another engine. So that comes the switching aspect. And then comes is the storage. So where we are relying on the huge amount of data that is stored everywhere in the world. Okay, so that's why we are saying that this accelerated infrastructure mainly needs to cater to these three domains. I just tried to give you the example of ChatGPT because for you it will be very much relevant and you will be able to correlate to that. Then mainly on the, I mean, coming back to slightly with respect to Marvel. Okay, so you have seen the three domains. So anyways, compute, interconnect, net switching as well as storage was already part of the previous slide. So in specific area, even if we are saying that it is a compute, so for us it is just a area, but inside that compute, it involves lot of complexity, whether it is a network processor or whether it is a wireless processor. Okay, all the computing things come into the compute. So mainly we cater to as wireless as well as networking processor. Then it comes to interconnect. So interconnect as well as switching. So wherever the data needs to move as well as get switched between multiple agents, we are calling it as a interconnect as well as a network switching. So mainly if you see the high speed ethernet, that comes under this switching and switching as well as interconnect. Then just keep the security aspect aside. Okay, the fourth point that we saw was the storage. So there we are saying that HDD, SSD, then all the fiber channel controllers. So all these storage related controllers come into this storage as a domain. Now coming to the security as an aspect, it was not listed earlier in my previous slide, but this actually is a key aspect of this complete infrastructure, because wherever you are, let's say, storing the data, you want to access a data, you want to process a data, and you want to share the results. There could be cases where you want this to be a very secured thing so that no one else knows about this. There could be cases where each organization wants to keep their storage as well as engine very specific to them. So they want to secure the data. So all the security aspect with respect to data as well as movement of the data comes under this security. So if you see, security will be there in all four domains, and it also is a very critical aspect of this infrastructure. Then coming to Marvel, so in Marvel, the data infrastructure end markets, we cater to data center, carrier infrastructure as well as the enterprise networking. So all these domains will fall under this accelerated infrastructure, and Marvel is contributing into the solutions related to those end markets. We also were contributing to the automotive thing, but that got spun off and it is part of some other organization. So we are not capturing it here. Now till now we have seen what is specific to market, what all things are happening in semiconductor. Now slightly coming to the area which you all can relate. So when we call it as a semiconductor solution, it has a specific life cycle that is involved in defining that solution till the solution becomes available to the market. So these are different steps that are involved in the semiconductor life cycle. You are slightly familiar with this chart? Yes, okay. So when you see each box will have a sufficient complexity that becomes a different group in a organization. So when you come to a system specification as well as architecture design, those two boxes are quite related to each other and both work together. Whenever there is any requirement in the market, these two, architecture as well as systems group, come together and try to find out what could be the solution for this problem, what could be the architecture that we need to come up with, what are the real needs from the customer side, which are the areas that we need to focus on, and they will think on the systems as well as the architecture aspect, and they will define the complete architecture of the chip. Then it comes to the architecture verification, formal verification, and the design entry. So this formal verification and architecture verification, those are two parallel tracks that generally happen, and those work very closely to the design entry. So after architecture level also, there are some aspects of verification that are involved to make sure that whatever is the architecture that we are coming up with will be really suitable. Do we need to tweak some things? Is there something that we miss to consider? So those things will be considered in the architecture verification and formal verification. And after that, we will come to the actual design entry part, where you say that the actual design is being coded using the HDL languages. Then after you do the design entry, there is a lot of parallel areas that start happening once the design entry starts. So one is the functional simulation, then formal simulation, then emulation, as well as FPGA prototype. Each caters to different complexity of this design entry, but the final aim is whatever is coded in the design entry is completely verified, tested. All the feedbacks will be given to the design entry team. They will change the things, and finally we will have a solution which we can see is matching to the architecture needs that were specified in the architecture. Then when we are confident that whatever is entered into the design entry is working as expected, we will start with the next cycle when it comes to synthesis, then static timing analysis, design for test. So whatever you are seeing after synthesis, we call it as a back-end flow, where it is really related to the gates, logic, transistor. All these concepts will start coming into picture after synthesis. So first, after synthesis, we will just have a translated version of the RTL. So HTL will get converted into the get level netlist. So that is the first level of translation that happens. Then after that, lot of things happen on that netlist. So design for test is one of the major area that is coming up now, because it really caters to the needs of design being tested on the real silicon. When you say the functional simulation or formal verification, it is happening on the HDL that we code. But when the silicon comes up, we need some testing strategy that we want to use, and the DFT is the area which caters to that portion, coming up with the architecture that will be available for us when the chip actually comes, and we will be able to identify are there any faults in that chip. Then static timing analysis, pre-layout simulation, physical layout. It is mainly converting the get level netlist that we have. It needs to be properly placed and route, because we have a limited area of chip that is being identified and agreed upon. So in that area, you need to fit your complete design. So the get level netlist goes through these things. There are multiple checks at every stage. I have not shown each and every feedback in this cycle, but there are a lot of feedbacks that happen even after synthesis. You can have a feedback to design entry. The design person needs to change some things, and the complete cycle can start again. Then when the netlist happens, you have the layout done. You try to fit your design in the area that you have given. Then you need to start identifying and checking whether your design is meeting the required frequency or not. Because when you have a architecture, you have the specific need of the clock frequency on which the design needs to work on. So that aspect will be checked in the mainly the static timing analysis case, as well as the post layout simulation. So mainly to make sure that your design is meeting the frequency requirement that is there in the architecture. If that is not meeting, then again there will be a feedback. The design people will go through the issues where all the design is not meeting the frequency. They will try to re-architect, they will try to recode, and they will give the new version of the design. And when we go through all these flow, once we reach the post layout simulation, we are sure that whatever we have coded is verified on all the aspects that we can do. Then we release that, we call it as GDS2 version. We send it to the fab where this particular thing gets fabricated, and then we get the silicon back. So till the post layout simulation, everything is considered as a fabless semiconductor organization. All these things are done by any fabless semiconductor company. After fabrication, once the chip is back, the it comes back to the organization who has designed that. First, that organization needs to verify that whatever is the chip output that we have is working as expected. So there is a next level of testing that happens after the silicon is back, that is being done using the tester as well as the post silicon validation stage. So if we find any issues in that, then we have to revisit. We have to see whether we can do some changes in the netlist. We can have a second tape out, and whether or the chip is working as expected, and we can make it as a production worthy chip. So this is actual semiconductor life cycle, where each and every chip that is there in any semiconductor device has to go through all these steps. And each and every box, even if now we are saying that it is a box, it needs a huge team to take care of that for a particular chip. At present, every organization will be working on multiple chips at the same time. So each and every chip team will need all these teams to make sure that the final chip output is available and it is working as expected. Okay, any questions on this? I know it is very heavy for all of you, but I just thought let me give you the idea about what all aspects of chip are being done, and each and every cycle needs engineers to work on these particular things and make sure that the things work as expected. Any questions? I will take a pause. No? Okay. Hope you all are getting. Okay. Okay, then coming to the contributions of Marvel India. So if you see, Marvel is in India we have three offices. One is in Pune, one is Bangalore, and one is Hyderabad. If you consider all three centers, these are the different areas where the India team contributes to Marvel as an organization. So if you see, right from the architecture, the Marvel India teams are contributing to semiconductor life cycle, and we also have the teams who are actually verifying the silicon. We have the teams who actually work on the tester. So huge amount of contribution in each and every stage in the semiconductor life cycle. Why I want to stress this is, generally many people have this what you can say thought that all the good work is being done out of India, and in India very less or very simple work is being done. So the things are changing. We are seeing the change. Earlier it was the case, but now India is a country. We are contributing into lot of things, and the contributions are very deep, and we get to work on lot of things where we completely own that aspect. So this is why I just want to share this. Maybe I will just wait for a minute for all of you to just go through this. Let me know if you are not understanding any of the point that is mentioned on the slide. Okay, we can move forward. Okay, then now after you all listen to this, then I also want to spend some time on different roles that anyone can play in the semiconductor organization. So I just try to create the broad level of domains that we cater to. So first, if you see design, verification, and simulation, we call it as a front-end organization of semiconductor that involves all these bullets that are mentioned there. Each and everything needs a strong engineer who is really passionate to work on these things and solve the major problems that are being part of this chip. So why I'm saying this is important is uh, when we say it is a chip, okay, it is a very huge and complex design. That chip will get divided into multiple different modules, you can say, which take care of, let's say, a networking aspect, memory aspect, compute aspect. Each of that domain will have independent architecture, independent sub modules involved in it, which will finally, when come together, will make that compute or networking as a portion of the chip. Hmm? So each of these things, even if you don't know everything in the semiconductor or everything in that chip, it is okay. You can only focus on a specific domain, let's say compute or let's say networking, and you can be expert in that and cater to that portion of the chip in each and every chip that is being developed by that organization. So these are the broad level things. So SOC architecture, when that single bullet is there, don't think that it is only a one person. Okay, this is a team which involves expert till the junior member. Each and every person gets an opportunity to contribute into that as per the expertise level they have. Hmm? So these are the different roles. Apart from the normal roles, we also have a specialist roles where nowadays we are seeing lot of new things are coming up, right? So AIML. So for considering the AIML aspect into the chip, we need a special architect who is expert in that. So that architect will come up to a solution, broad level solution or broad level problem that we want to solve, then create a solution for that, and then that will get translated into a design idea. So not only these roles, there are lot of multiple specialist roles that we need in the cycle. Apart from this, if you are, let's say, very much passionate about management aspect or productization aspect, then we also have a lot of roles in that business and marketing area. We also have different corporate functions that are required. So if you see, semiconductor organization is a full-fledged organization which needs the experts in all these domains. And if there are engineers who are really passionate about these things, they will get an opportunity to work on all these aspects as per their interest. Hmm? Any questions on this? No? Okay. So now I have covered my part which I wanted to share with all of you. Now we also have a second part of this presentation where I have two of our interns who are part of your college, who are part of our organization. They are acting as an intern. So I would also like to ask them to share their views. So the part after this will be taken care by them. I will be able to help wherever you need. Okay? Yeah, thanks everyone. I can move the slides if you want.
Thank you, Madhura. Okay, so I'm Arya Kokate. We have Ketki also with us. So it feels a little different. Few months back, we were on that side, and then today we are here. So we are very overwhelmed with this also. And as Madhura said, we get to work on actual projects also here. So we don't feel that okay, we are interns, we are getting some dummy projects to do on. No, both of us are working on live projects as of now. So it's our third month of internship, and then like after 3 months also we are getting to work on live projects. There is a lot of nurturing also that is done here um, for the tech part, and as well as the skills, the soft skills that we tell. So we actually have a lot of sessions for the interns also. We get to learn a lot of things. There's a lot of learning in Marvel, and we can say this with our own experience. Last year, we trusted Madhura because she's an alumni, and then she was there for the pre-placement talk, and then we were very overwhelmed to see her being at such a great position in Marvel. And then now, when we are actually getting to work, we are seeing the industry exposure also, getting to work with our teams. So I am a part of the validation team. So pre and post, I am a part of both the teams. Currently, as an intern, I'm working mostly in the post silicon. So I've seen the actual boards. I have worked on it. Yes. So and everybody here at Marvel is very much supportive. Like you can go, you can connect with the managers, you can connect with the directors. Everybody is here. Like they're very helpful. You are never treated as someone who's intern. So yeah, so that is our experience. We have even the campus ambassador thing, which the university relation team handles. So there also a lot of events are happening. There's a lot of networking that happens, and we are encouraged to do a lot of things. Like more often, the networking part is very much encouraged here. We don't hold ourselves back because they encourage us in every aspect, the technical, the soft skills, everything. So yes, that we are very much into deep learning now. I would like to handle it to Ketki now. Thank you.
Hello everyone, I am Ketki Vavaskar. I am a final year BTech student from ENTC department and a very proud Marvel intern. So currently my role is hardware and silicon validation intern. I remember Arya saying that few months back we were on this side. It is quite true. We were sitting somewhere in the somewhere between on the third row, and we were looking at Sandini and Madhura talk about the organization, talk about the experiences, talk about the roles, talk about the opportunities that Marvel can give us. And today, being on this side, with a new identity, with a Marvel identity, the journey has been incredible. I would like to say that listening about an organization and actually getting to work in that organization is quite different. And the best way you can do it is like actually experiencing that organization. I would say like more emphasis that we do get to work on live projects. We do get to work on interesting projects. Even though we are still interns, we are given a lot of responsibility. We are given a lot of importance as well. And I would say that every single day we get to learn anything. Like we get to learn new things, not just technically but also non-technically. Also, I'm in the pre and post silicon validation, so even I do get to work on the both. So it's a very different experience. Learning something in college is different, and actually getting to work on live boards is different. I would say that not just emphasis on technicality, but networking is also a very huge aspect at Marvel. People are very approachable. I would like to say that you just can go to someone and you can just ask them about something. They're always ready to help you. They're always ready to listen to you. They can guide you. They're always there for you. Apart from this, in a team, we do feel that there is importance on our role. We do feel that we have an opinion. And whatever we are giving to the team, they are also considering us. So that is one thing. And apart from the internship, apart from the projects, apart from the work that we do, apart from the tasks that we get, we do also get to have a lot of interesting extracurricular activities as well. We have incredible intern programs as well, where we get to tell the organization what we want, and they do provide us that. So overall, I would like to say that Marvel is a very good organization to work at. And so yes. Also, we do have one quiz for all of you. So we'll just put the questions on the board, and if you know the answer, please do raise your hand. We do have exciting goodies for you. First question is, which semiconductor device is commonly used as a switch in digital circuits? Okay. Maybe you can check who is. okay without the mic because. Okay, anyone else? Yes, yes, that is correct. Uh, Please clap, guys. Second question is which type of transistor is commonly used in digital integrated circuits? Green? No. Anyone else? No. Yeah. Mhm. It was a trick question for everyone. What is the name of the process used to create patterns on a silicon wafer? Come on, more guesses, please. Okay. Who is considered the father of engineering in India and is honored on Engineers' Day? Do you know what today is? Yes. It's a good day to have this session. Which Indian engineering institute was the first to be established? Raise your hand, raise your hand. Please. It is correct. Arya, it is correct. Next question is what is the name of the Indian engineer known as the Metro Man of India? Does anyone know? Okay, I'll just quickly read the options. First is M. Viswasarya, second is E. Sridharan, C is Nandan Nilekani, D is Raghunath Masharkar. Yes, sir? Okay, it is correct.
Okay, then now let me just see who all were very much engaged in the sessions. Okay, uh, so I will now ask some of the questions from the slides which I presented. Huh? So
हम्म? काय ते हेलो चेक 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 1 2 3 4 5 6 7 8 9 0 चेक हेलो चेक 1 2 3 4 5 6 7 8 9 0 चेक 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 check, 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 check. 1, 2, 3, 4, 5, 6, 7. तुमची इथं ओके. व्हॉट्सअपला मला टाका फक्त आवाजाचं. इथं हे माईक ऑन केलं का हमिंग येईन मग लगेच. हॅलो, चेक 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 चेक. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. चेक 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 चेक. येतोय का आवाज? हां. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. अजून पण बारीकच आहे का? सिंग सर बघा जरा आवाजाचं सेटिंग. हां, वरचं गेन कमी करा. हां तेच. चेक 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 0, 9, 8, 7, 6, 5, 4, 3, 2, 1. हो सिंग सर बघा ना आवाजाचं, बघा ना थोडंसं वाढवा ना. तिकडे कमी जातो आवाज. हां. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 0, 9. तुमच्या इथलं वाढवलं का आवाज मॅडम? तुमच्या इथला आवाज फुल केला का? हॅलो, चेक 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. मॅडम तुमच्या इथला फुल आहे का पूर्ण? चेक 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 0, 9, 8, 7, 6, 5, 4, 3, 2, 1. सिंग सर होत नाही अजून ते काही. हॅलो, चेक चेक चेक. तिकडे आवाज कमी जातोय. चेक 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 चेक. 1, 2, 3. ऑक्झिलरीचं वाढवा ना. ऑक्झिलरी हे काय ग्रीन आहे ना ही. हॅलो, चेक चेक चेक. बघा मॅडम. चेक 1, 2, 3, 4, 5, 4. चेक करा मॅडम, मला सांगा फोनवरती. चेक 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 चेक. 1, 2, 3, 4, 5. ही इथनं वाढतो ना ऑक्झिलरीचा. ही ऑक्झिलरी निळ्या बटनात ना. ऑक्समध्ये द्या ना मग. ऑक्स काय? चेक 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 चेक. 1, 2, 3. आता बघा ना, आता वाढला असन. चेक चेक चेक. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. हॅलो, चेक चेक चेक. 1, 2, 3, 4, 5, 6, 3, 2, 1. चेक 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 चेक. हां, येतोय व्यवस्थित? हॅलो, चेक चेक चेक. 1, 2, 3, 4, 5, 4, 3, 2, 1. आहे का आता व्यवस्थित? आहे का आवाज योगिनी मॅडम? हॅलो हॅलो. हॅलो, आहे ना व्यवस्थित? करू बंद मग? हां कमीच वाटतोय. अजून थोडंसं वाढवतो मग थांबा. आता बघा चेक 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 1 2 3 4 5 6 7 8 9 0 1 2 3 4 ब्रेक झाला. हॅलो चेक 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 1 2 3 4 5 6 7 8 9 0. आता चांगलं येतोय ना. बरं ठीक आहे चालते ओके. हो हो हे ऑक्झिलरी ना इथून वाढवायचं बघा.